Hello, today we're going to start looking at three-dimensional problems, and this should be on page 62 of your notes booklets. So if you need to, you can pause to get your notes booklets now and open up to page 62, where we'll look at the two problems here. Just before Christmas, I said to you that it was useful to maybe get a string which you can keep in your pencil case and you're allowed to take into exams to help you to visualize your three-dimensional problems, because all of the diagrams are going to, of course, be drawn in two dimensions, and you have to try and visualize that. So it can help if you have a string and your pen to sort of step up and see how the right angles don't change when you're drawing. If you have like one vertical line like this, when you're drawing triangles that reach to various different edges. And most of what three-dimensional problems are going to be about is about finding those right angles in the diagram. So as is noted in your notes up here, when you have three-dimensional problems, you're going to need to, I'd say even before you redraw any individual triangles, I'd change the order here, identify your right angle triangles, redraw them, and there will be some non-right angled triangles as well, but almost all the time these are about right angled triangles. So non-right angled triangles too, and then use the appropriate ratio. What do they mean? SOHCAHTOA, or Pythagoras, or the sine or cosine rules. And again, remember, these are only for non-right angled triangles to solve for whatever we're being asked for. It takes a bit of practice before you'll get the knack of identifying the triangles and thinking in three dimensions. Some of you, it'll just come naturally, and some of you will really have to practice with looking at things. Maybe get a box or something like this and use your string, or use a piece of cardboard or something to look at the inside and look at how triangles can be formed if you're doing something like the picture that we have here. So if I imagine a cube and I'm drawing a triangle where the vertical edge of the triangle is back here, and the point, the vertex that they're talking about down here, is all the way on the opposite side. So you're kind of drawing a slice through the box. Now, let's take a look at the example that they've asked us to do here. Example 1. Just move this. Hopefully you can see okay. I apologize for the angle. This will get better. I'm just waiting for some equipment to arrive. So in this diagram, we can see a cube and it has side 5. That means all of the sides are 5. 5 going up, 5 going back, and 5 going across. Find the measure of the angle between the diagonal AD, so from the top of the cube over here, all the way down to the bottom of the cube on the other side. And they want us to find the angle in here, and they've provided a diagram which is helpful. They don't technically have to, but they almost always do. And the base of the cube, as shown here. So the first thing is identify a right angled triangle. And as I've been explaining, this triangle in here, this triangle AHD, is a right angled triangle. If you don't see that, then just work with your string and a cube that you can find around your house somewhere. The triangle AHD is a right angle triangle. And where is that 90-degree angle? Well, it's between the vertical and the base. So if I sketch out this triangle, redraw the triangle with AH going straight up like that, and HD is along the ground. So my 90-degree angle is in there. Okay. So we want to find the angle theta in here. Do we have enough information? Well, we know that this is 5, but do we know HD? We don't know that, so let's call it X. But look, this is a side that's part of another triangle, HED. Now remember, the base of my cube, even though it looks like it's not got any right angles in it the way it's drawn here, of course it does. It has 4 right angles in it. So if I draw out the triangle HED, this is also a right angle. So the other triangle that I have HED is also a right angled triangle, and E to D, as we can see here, is 5. Also, H to E, also side of the cube, is also 5, meaning that we can use Pythagoras' theorem to find HD. And the HD, that's the hypotenuse in this triangle, is the base in this triangle. So I use Pythagoras. And by Pythagoras, let's move this over here. By Pythagoras, we can work out, because that's the hypotenuse, my hypotenuse squared is the other 2 sides squared and added together. So x is going to be the square root of 50, which is 5 root 2. When you type it into your calculator, it'll simplify to 5 root 2. So now I know this value here, and I can fill it in 5 root 2. I wouldn't change that to a decimal, just leave it as a third. Okay, now I want to find an angle. A right angled triangle, when we start talking about angles, it means we're dealing with SOHCAHTOA. Sorry, it's shaking. We're dealing with SOHCAHTOA. So that means what I'm going to do next is, using my first triangle here, I'm going to label the sides. That's my hypotenuse, that's my angle, so that's my opposite, and that's my adjacent. The 2 sides that I know are the opposite and the adjacent, so I'm using tan. Tan of theta is opposite over adjacent. And I can fill that in. That's going to be 5 over 5 root 2, which is 1 over root 2. And when I'm looking for the angle, I have to use my tan inverse function. So tan theta is 1 over root 2, which means that theta itself is going to be, let's move this over a bit, tan inverse 1 over root 2 Make sure that your calculator is in degree mode, and we do tan inverse 1 over the square root of 2, and that's 35.26 degrees. 35.26 degrees. And that's our answer. So we found the angle that they asked us for. Okay, that's the basic idea. Now they do get a little bit more complicated than that. So let's move straight on to the pyramid question that we have down here. So a little bit. Just trying to make sure that we can see. Okay, so this question says, the pyramid shown has a square base where the side is 4 meters and the vertical height is 3 meters. Here's the thing you want to look out for. When you have a vertical height, you always have something going straight up, and a flat ground, which means you will always have a 90-degree angle at the ground. So straight away, if I look at my diagram down here, just zoom in a little bit, I know that this will be a 90-degree angle. It has to be. Because this is a square base, I know that these corner angles are also 90 degrees. Okay, so there's where my right angle triangles are going to come from. The first thing I'm asked to do is to find the length of the edge AV. So let's just highlight that. The length of this edge here is what we're asked for. Okay, let's draw out the triangle that contains AV. It's going to be the triangle AOV. I draw it out like this. My 90-degree angle is between the vertical, OV, and the ground down here, A. Okay, do I know any of those values? Well, I know the vertical height because they told me that the vertical height is 3 meters. But I don't know OA yet. Well, what do I know? Well, it's kind of half a diagonal, so it's very similar to our last question, where we had on the base of the cube, we were using the side going through the diagonal. So let's look at the full diagonal, because if I can find A to C, then I can divide it in two and find A to O. So if we look at the triangle, I'll put it down here, ADC, and I have a right angle at D, as I've drawn in there. AC, A to D and D to C are both 4 units long, so I can use Pythagoras to find A to C, the hypotenuse. So by Pythagoras, we can work out that our hypotenuse squared is the other two sides squared and added together, and that gives us 32. So h is the square root of 32, which is 2 root 4. Now, we don't want A to C, we want A to O. So therefore, the distance from A to O is just the I apologize, guys. 2 times the square root of 4. Square root of 32 is 4 times the square root of 2. I just wrote it backwards. Let me just fix that. So that's 4 times the square root of 2. So A to O is going to be half of that, 2 times the square root of 2. Okay, so we can just divide it by 2 in our calculator and we get 2 times the square root of 2. So now I can fill that information in to my diagram up here. 2 times the square root of 2. I was asked to find the distance from A to V, and that's the hypotenuse as well. So again, by Pythagoras, we know that h squared is the other two sides, 2 root 2 squared plus 3 squared, squared and added together. So that gives me 8 plus 9, which is 17. Just move this over. And h is equal to the square root of 17. And we have our first answer. That's A to V. The distance from A to V is the square root of 17. You can write in units, no units were given. Oh no, they're meters. It's in meters, so answer in meters. If they don't give anything, you don't have to write anything, but if they do, you must fill it in. Okay, so that's part one. Part two, they asked us to find the total surface area. So we need to find the area of the base. Let's take a look at this diagram again. The area of the square base and each of the 4 triangles. So the square base should be easy enough to do. And just so that I can write a little bit bigger, I'm going to use different paper for this. So my total area, but you can take it down smaller into your own notes. The total area is going to be the square base plus 4 triangular faces. Now the square is easy enough, so let's do that first. I'll just move this up here. Make sure everything we want is in screen. The square base well, each side is just 4 units long, so that will be 4 by 4, which is 16 meters squared. But what about the triangles? Well, let's look at one of them. I'm just going to draw out the front one here. A, V, D. We know we've got 4 down here, and we've just calculated that this is the square root of 17. Now, what kind of triangle is this? In order to have a square base, and in fact in every pyramid question that you have, the slanty triangles that make up the faces will always be isosceles triangles. And the great thing about isosceles triangles is that you can divide them into 2 equal right-angled triangles. And that means that I can, let's just call this the point P in the middle. I can draw a triangle like this. A, V, P. And now I have this information, and that's a right-angled triangle. Okay, why did I do that? Because now I can find the distance from V to P. But why do I want to do that? Because in order to find the area of a triangle, I want to use a half the base by the perpendicular height. And here's my perpendicular height. Okay. Excuse me. Okay, well, of course we have another area formula, but we didn't have any angles here. We could have done a lot more work to find the angle at V, but this is the easiest way to do it. So I want to find that perpendicular height here, and I'm going to use Pythagoras' theorem. So by Pythagoras, it's not the hypotenuse this time. The hypotenuse is the square root of 17. It's the other 2 sides. 2 squared plus perpendicular height, even though it says h, is equal to the square root of 17 squared. And so we get 4 plus h squared is equal to 17, and h squared is equal to 13, and h is equal to the square root of 13. Okay, so now I can find the area of my triangle, which is going to be a half by the base. It's the full triangle we're talking about here, so the base is 4. Half the base by the perpendicular height, which is the square root of 13. And that is 2 root 13 meters squared. So now I have the area of my square base. I have the area of one triangle. So the area of 4 triangles will be 4 times that, which gives me 8 root 13 meters squared. And the total area will be 16 plus 8 root 13 meters squared. Can I leave it like that? Well, let's go back and see what they asked us. They said to the nearest meter. So all you have to do is type that calculation into your calculator. 16 plus 8 root 13, and press the change button. 44.84. .45 meters squared. Of course, the question was misphrased. It should have said to the nearest meter squared. Okay, so that's the answer to part 2. You don't have to write down every step that we have there. I just wanted to make it clearer for when you guys are filling it into your notes. Now, for homework, I'd like you to try a couple of those questions yourself. And in tomorrow's video, I will go through the corrections of that. So homework is going to be page 121, questions 1, 2 and 3. And of course, I'll upload a screenshot of those and write in the page number on Google Classroom as well. Okay, thank you very much. Talk to you tomorrow.